Good morning, students. Today we are going to see theoretical distribution in probability theory. So there are two kinds of theoretical distribution. One is a discrete theoretical distribution. Another one is a continuous theoretical distribution. So in 12th standard, in our chapter, we have only discrete theoretical distribution. So there are four special cases in discrete theoretical distributions. So we are going to see the two. One is Bernoulli distribution, another one is binomial distribution. Okay, we'll move to Bernoulli distribution. Before knowing to Bernoulli distribution, you should know what is Bernoulli experiment. So Bernoulli experiment is a random experiment where the outcomes are classified in one of two mutually exclusive and exhaustive waves, say success or failure. So in the first point, Bernoulli experiment is a random experiment which has only two possible outcomes. You can take an example, tossing a coin once. So while tossing a coin, you will get head and tail. There are two possible outcomes. If you consider getting head is a success, means getting tail is a failure. So you will have two possible outcomes. Okay, how the outcomes are? They are mutually exclusive. Getting head is mutually exclusive from the event getting tail. Okay, they are mutually exclusive. If you join head and tail, you will get the sample space. So if A union B is equal to yes, those events are called exhaustive events. So therefore, Bernoulli experiment is a random experiment which has only two possible outcomes. One is success, another one is failure. Okay, coming to the second point, a Bernoulli experiment is performed several independent times so that the probability of success remains same from trial to trial. Okay, you see now, it can be that Bernoulli experiment can be repeated several independent times, but the probability of success remains same in the each trial. You see that tossing a coin 4 times. So if you tossing first time, you will get head. Getting head means, so the probability of getting head, the probability of getting head is 1/2. So if you toss fourth time, if you again you are getting head, means the probability of getting head in the fourth time also 1/2. So the probability of success remains same for all the trials. Okay, those experiment is called Bernoulli experiment. If you repeat the Bernoulli experiment several independent times, you will get a sequence of Bernoulli trials. In that trial, the probability of success should remain same. Now we are moving to the Bernoulli distribution. Bernoulli distribution. Let x be a random variable associated with the Bernoulli trial. You see the word, the random variable associated with the Bernoulli trial. That means the Bernoulli trial is what? Which has only two possible outcomes. One is success, another one is failure. It can be repeated several independent of times. The probability of success remains same in all the trials. That is called the Bernoulli trial. Okay, so by defining it as x of success is equal to 1. What is x? X is the random variable. X is denoted as number of successes for the Bernoulli trial. X is denote the number of successes. That is number of success. Okay, x is number of successes. You see now, x of success, if we get success means the value of the random variable is 1. If you get failure means the value of the random variable is 0. So therefore your probability mass function. So probability mass function. Okay. Otherwise we can denote it as P of x is equal to x. That is P. P is what? It's a probability of success. When you are getting P when x is equal to 1. So x value is 1, that is number of successes is 1 means the probability is p. So x equal to 0 means you are getting failure whose probability is q. Okay, q can be written as 1 minus p. Why it's so? You see, only two possible outcomes. Success probability is p. The failure probability is q means, okay, they are exhaustive events. So if you add all the probabilities, you will have only two probabilities. One is p, another one is q, because those events are exhaustive events. Okay, those events are exhaustive events. You see now, the probability of success is p and the probability of failure is q. Only two outcomes whose probability is p and q. If we add, the total probability is 1. So therefore p plus q is equal to 1. So therefore q is equal to 1 minus p. Okay, so this x is called the Bernoulli random variable and f of x is called the Bernoulli distribution. Okay, so the Bernoulli distribution is defined for when x is equal to 1 and x is equal to 0. Next we are moving to the distribution, binomial distribution. It is an important distribution which applies in some cases for repeated independent trials where there are only two possible outcomes. In the binomial distribution, we will use Bernoulli trial. You see the difference. Okay, suppose a coin is tossed once. We'll take a coin, it is tossed once means if x denotes number of heads, x denotes number of heads. So while tossing a coin, what are the sample space you will have? You will get head and tail. So you will get head and tail. Here we have denote getting head, the x denotes the number of heads. So when you are getting head, your x value is 1 because number of head is 1. If you get tail, x value is 0. So you will have 1 and 0. X is 1 and 0. So therefore x follows Bernoulli distribution with the parameter p. That is, when x equal to 1, the probability of success is p. When x equal to 0, you will get failure, that is q, that is 1 minus p. Okay, now if suppose this trial is repeated 4 times, suppose a coin is tossed 4 times means, here also x denotes number of heads. 4 times it is tossed. So therefore the values of x, how they are? 0. That is, the 4 times also you are not getting head. That is, number of head is 0. Okay, number of head is 1, number of head is 2, number of head is 3, number of head is 4. You can have this much value. You know very well. So we are going to find the probability. See now, when x is equal to 0, x equal to 0 means what? You are not getting head. All the 4 times you are getting tail only. Getting tail is a failure whose probability is q. So therefore q into q into q into q. So therefore q power 4 is written. You see now next, x is equal to 1. X equal to 1 means what? X is equal to 1 means the number of head is 1. Number of head is 1. So that means only one time you are getting head. The remaining time you are getting, what is only one time you are getting head, the remaining time you are getting tail. So getting head is your success and getting tail is your failure. So how many times we are getting success? Only one time. So whose probability is p. Whose probability is p. And how many times you are getting failure? 3 times. So therefore each time the probability of failure is q. So q into q into q, that is q. But you are getting success out of 4 times. So which time you are getting success, we don't know. So therefore it can be done in 4C1. So out of 4 coins, you will have only one coin having success, that is having head. So therefore 4C1 into P. Okay, so here we can write when x is equal to 1. X is equal to 1 means it is only one time you are getting success, that is P. The remaining 3 times you are getting failure, so that is Q cube. So the success can be done for C1. Okay. At the next, x is equal to 2 means what? Number of heads is 2. So 2 times you are getting head and the remaining 2 times you are getting tail. So therefore it is p squared. Why it is p squared? The probability of getting head is p. So 2 times you are getting, so p squared. And 2 times you are getting failure. So it is q squared. So this can be written as 4c2. So out of 4 coins, 2 coins you are getting, what is it? Getting a head. So therefore 4c2 p squared q squared. When x is equal to 3 means 3 times you are getting head and the remaining 1 time you are getting tail. So therefore it can be done 4c3. 4c3, what is it? P cube into q. Okay, and all the 4 times you are getting only head. That means it is p power 4. So no tail. So it is q power 0. Otherwise you can write 4c4. Okay, so here also we can write, what is it? 4c0 p power 0, because in all the 4 coins you are getting only tail. So therefore the success is 0. So therefore 4c0 p power 0. In this way also you can write. So therefore if x follows binomial distribution, what is it? If, see, from this, if we can write the probability distribution, generally we can write as NCX. Okay, NCX p power x q power n minus x, where x varies from 0, 1, 2, 3, etc. up to n. Okay, so therefore the trial is finite. The trial is finite. That means n times if you are repeating. Here I have given example for the coin is tossed 4 times. Okay, you know very well about it, how to write. So if it is repeated n time means the Bernoulli trial is repeated n time means we can go for the probability is p of x is equal to x is equal to NCX p power x q power n minus x. Here n is nothing but the number of trials and p is nothing but probability of success and q is nothing but probability of failure. So q is equal to 1 minus p. Okay, so from this, okay, I'll explain with the simple example. Now we'll see the definition of the binomial random variable. A discrete random variable x is called binomial random variable if x is the number of successes. The random variable x, that is a discrete. Okay, it is a countable number of values. So the value is finite. So it is called binomial random variable means x is the number of successes in n repeated trials. N repeated, we can write Bernoulli trials. How the Bernoulli trials, that is explained in the 3 steps. Okay, how the trial, first one, the n repeated trials are independent. Okay, and n is finite. Okay, the trials, you can repeat the trial, so n times, so n repeated trials are independent. That is the probability of the trial, what is that, should not affect the another trial. Okay, so therefore the n repeated trials are independent and n is finite. Okay, and you see each trial results only 2 possible outcomes. One is success, another one is failure. The third one, the probability of a success in each trial remains constant. So the probability of success is what? We can denote it as P. So P remains constant in each trial. So the random variable called binomial random variable. So the binomial random variable means it follows binomial trials. Binomial trial means, what is it? It has only 2 possible outcomes. It can be repeated n independent times and each time the probability of success in each trial remains constant. Okay, if the random variable follows these conditions, that is called the binomial random variable. So now we are moving to the binomial distribution. So if x follows the binomial distribution, how it will be denoted? X follows binomial distribution with the parameter n comma p. Okay, so that variable is a binomial random variable whose probability mass function f of x, how it should be? ncx p power x q power n minus x, where x varies from 0, 1 to etc. up to n. What is small n? Number of trials. How many times the Bernoulli trial is repeated? That is your n. What is p? It's a probability of success. What is q? The probability of failure. So it has only two possible outcomes. They are exhaustive. So therefore the total probability is 1. So p plus q is equal to 1. So q is equal to 1 minus p and p is equal to 1 minus q. Next, the binomial distribution. What we should know now? We should know about the mean and the variance of the binomial distribution. So the mean is, it is denoted by the letter mu, that is equal to np, and the variance is denoted by sigma squared, that is npq. Otherwise, in the place of q, what you can write? 1 minus p. Okay, you should know about this. Now we are moving to the exercise 11.5. Compute p of x is equal to k for the binomial distribution, that is b of n comma p. That means b of n comma p means that x follows binomial distribution. In that binomial distribution, you will have the two parameters. One is n, another one is p. What is n? It is a number of trials. What is p? The probability of success. You see the first subdivision, n is equal to 6. So the trial, it is repeated 6 times, and the probability is 1 by 3 for all the trials, and k is equal to 3. Where is k? We have to find out p of x is equal to k. Now in the first subdivision, your k is equal to 3. So here it is mentioned that x follows, the random variable follows binomial distribution. So you should know about the probability mass function. The probability mass function can be denoted as small f of x or probability of x is equal to x. How you can write? The formula is ncx p power x q power n minus x, where x varies from 0, 1, 2, etc. up to n. Here what are the results are given? N is given and p is given and k is equal to 3 is given. So substitute here. What is needed? Q is needed. You know that in the binomial distribution, the random variable is making Bernoulli trials, isn't it? So therefore q is equal to 1 minus p. So it is 1 minus 1 by 3, that is equal to 2 by 3. So take this result, p of x equal to x, substitute in the place of n as 6, in the place of p as 1 by 3, and in the place of q as 2 by 3. Okay, so here n minus x, so therefore 6 minus x, where x varies from 0, 1, 2, etc. up to 6, because n should be finite. So therefore 0, 1, 2, 3, etc. up to 6. Here, what is asked? P of x is equal to k. So in the first subdivision, what is k? It is 3. So what is asked? P of x is equal to 3 is asked. So in the place of small x, you have to substitute 3. Okay, so therefore p of x is equal to 3. That can be written as 6c3. Right, so here you are having 6cx. Now your x is 3. So 6c3. 1 by 3, the whole power x. In the place of x, you have to substitute 3. 2 by 3, the whole power 6 minus 3. 6 minus 3 is 3 here. 6c3, you know very well. 6 into 5 into 4 divided by 1 into 2 into 3. So 1 by 3 cube, so therefore 1 by 27. 2 cube is 8 and 3 cube is 27. So the 2 3s are 6. So it is cancelled with the numerator 6. So here you are having 5 4. 5 into 4 is 20. 20 into 8 is 160. Divided by 27 into 27, that is 729. Okay, coming to the second subdivision, n is equal to 10, p is equal to 1 by 5, k is equal to 4. So you should know about binomial distribution. If you want to substitute, you should know what is n, what is p, and what is q. So q using the formula 1 minus p. So 1 minus 1 by 5, that is equal to 4 by 5. So you substitute in the formula. What is the formula? If x follows binomial distribution, the probability mass function, what is it? P of x is equal to x is equal to ncx p power x q power n minus x, where x varies from 0 1 2 etc up to n. Okay, here you are going to substitute in the place of n as 10, so it is substituted. In the place of p as 1 by 5, and in the place of q as 4 by 5. So it is whole to the power 10 minus x. Now your x varies from 0 up to 10 because your n is 10. Now what is asked? P of x is equal to k. So in this problem subdivision, you are having k is equal to 4. So what is you have to find P of x is equal to 4. So here in the place of x you have to substitute 4. So it is 10c4 1 by 5 the whole power 4 and 4 by 5 the whole power 10 minus 4. So you see now 10c4 1 by 5 the whole power 4, 4 by 5 the whole power. What is 10 minus 4 is 6. Okay, so 10c4 can be written as 10 into 9 into 8 into 7 divided by 1 into 2 into 3 into 4. So see now 2 is 2 and 10 cancel means you will get 5, and 3 and here 9, so your answer is 3 here. 4 into 4 and 8 divided by 4 is 2. So here the remaining is 7 into 7, 1 by 5 the whole power 4, 4 by 5 the whole power 6. So if you calculate, if you multiply these four numbers, you will get 210. The remaining you can keep as it is. So coming to the third subdivision, n is equal to 9, p is equal to 1 by 2, k is equal to 7. So q is substituted using the formula 1 minus p. Then you have to write the binomial distribution. In binomial distribution, the probability mass function, where x varies from 0 1 2 etc up to n. On that you have to substitute what is n. N as 9. What is p first? It is 1 by 2. And what is q? That also 1 by 2. Whole power 9 minus x. Now your x varies from 0 1 2 etc up to 9. So here what is k is given? 7. So in the place of x you have to substitute 7. So it will become 9c7 1 by 2 the whole power 7, 1 by 2 the whole power 9 minus 7. What is 9 minus 7? That is 2. 9c7. You know that in combination we'll go for NCR is equal to NC n minus R. What is it? NCR is equal to NC n minus R. Using the formula, you see now I have written clearly here, NCR is equal to NC n minus R. Okay, see here you are having 9c7. Okay, 9c7. So it can be written as 9c9 minus 7. So that is equal to 9c2. So 9c7 can be written as 9c2 here using the formula NCR is equal to NC n minus R, half power 7 and half the whole square. 9c2 can be evaluated. So 9c2 can be written as, you see that 9 into 8 divided by 1 into 2 into 1 by 2 the whole power 7 into 1 by 2 the whole square. So if you multiply, your answer is 1 by 2 the whole power 9. So 8 by 2 is 4. So 9 4s are 36. 36 into 1 to the power 9 is 1. So the numerator is 36 and the denominator 2 power 9. What is 2 power 9? It is 512. If you cancel with 4, you will get 9 by 128. Thank you, students.